Ruchi Singhal. I am the Director of Facility and Infrastructure at Syntel, and I'm also the founder and board chair of Nexus Energy Center. Nexus Energy Center is a local nonprofit organization that I started in 2010. I'd moved to Huntsville in 2008. I really loved the people here, and I wanted to see what we could do to do more energy-related work. After I was seeing all the space and defense-related work that was going on in Huntsville, I felt like energy was a natural fit. And I'm proud to say that I feel like I'm one of the founders of the energy movement. All of these enthusiastic people that you see planning today's and yesterday's, the summit, the Energy Huntsville pioneers, I was probably one of them pushing along to see, can we get something accomplished in this great town? And although we still have a long way to go, I'm really proud with what we've been able to do. I wanted to talk a little bit briefly just about Nexus Energy Center and what we've been able to accomplish. And I encourage everybody to, just like I was telling you those dates to write down, I encourage everybody to like our page and to go to our website, www.nexusenergycenter.org. And the reason is it benefits you. So what Nexus Energy Center does is we educate the community about energy efficiency and how you can save in your home or at your small business, and how the people who really need to save, the underserved neighborhoods, how can we really bring awareness to that problem, but not just awareness, how do we actually help fix it? And we do that with our Comfort Project. And I think everybody would be really proud to be involved in some of these Nexus Energy Center programs. And if nothing else, you may want to just lower your own utility bill, and that's our bread and butter. That's how we help people. So please, please check us out. We're a great organization and someone that you can benefit from. I also wanted to talk about Syntel. Syntel is an up-and-coming small business, government contracting business here in Huntsville, and we have some amazing projects with the federal government on energy, and that's kind of my space there at the company. I also am really proud about the data analytics work that we're doing there, and what I'm learning every day is how the more you know, the better decisions you can make, and the way to know more about your data is changing every day. And there are some really great new tools and scientists that are working on looking at a lot of data in a smarter way so we can understand what's the correct decision to make to save energy. And that's been very exciting because we've been able to implement that data analytics at the Air Force, for the Marine Corps, at the Army level, and we're really seeing these big users benefit from understanding their copious amounts of data. And that's kind of what we do. So we want to help anybody out there who has challenges with that. And really everybody qualifies. I know I've met with a lot of the people on our panel today to talk about that because I really believe that they want to be able to make better decisions at their facilities that really show the results they need, right? So instead of it being a guessing game or this is how we always did it, how can I really understand how to save based on how I've been performing? So it's kind of a game changer, which is exciting. You know, I'm an engineer. I did my chemical engineering at Georgia Tech and my master's at NC State. Go Pack. And I'm really proud of what I was able to experience through my education and through my work. But what's more exciting is that I'm still learning. After all those years of school and my first few jobs, I feel like it's still evolving into doing things better, and that's what really excites me. I hope it excites you. I see a lot of students in the audience. I'm so grateful to have you guys here. I think you'll learn a lot, and we hope that we stay in touch with you because you're the future of how all this gets done. So with no further ado, I'd like to introduce our first panelist. We have the famous Janine Horton. I say famous because I've known Janine forever, and she's always the person I was like, have you talked to Janine about this? Have you talked to Janine about this? She's been helping the community in Huntsville on energy issues and is a shining star at Toyota. She's a manager at Toyota Motor Manufacturing in Alabama. We call that TMMAL, in the Environmental and Facility Department. She's led the company's environmental management systems for several years. Her position requires widespread responsibilities, including the development of annual environmental management plans. We've been talking about planning a lot today, ensuring department collaboration on action plans, and development and execution of the TMM-AL 2025 CO2 reduction roadmap. Thanks to Janine, TMM-AL has achieved numerous environmental awards and certifications, resulting in its position as a clear leader among Toyota's manufacturing operations. Janine?
Okay, thanks, Rishi. That was some big shoes to fill, but hopefully I'll be okay.
Do you want to be at the podium?
Yeah, you can see me.
Yeah.
That was a running joke. Rishi was like, can you see me? Can you see me? Most people say, can you hear me? Can you hear me? But that's okay. So as Ruchi said, my name is Janine Horton. I've been with Toyota quite a few years. I've been in environmental and facilities well over 20 plus years. I started to date myself. I guess this is working. Oh, there it is. Oh, sorry. There it is. That's me. Like I said, I've been at Toyota now 16 years, roughly 24 years of environmental experience and a couple of certifications that I hold. So really quickly today, I'm just going to tell you a little bit about Toyota, and I'm telling you this in the perspective of the investments in the U.S., and then what our environmental and energy outlook is, and then some of the things that we've done here locally that we would want to share with you guys. Maybe you can Yokotan it or, adopt it in your facilities. Oh, you told me I was pointing the wrong way. Okay, just really quickly, we're in North America. We are an American company. We have Japanese parents, but we've been in the U.S. for a while, so we are American. We have over 10 facilities. I work at the Alabama plant, and just recently, I've transferred to the Mississippi plant, so I'll be away from my city for a few years in Tupelo, Mississippi. We have Clark in the back. She'll be doing a lot of, wave at him, Clark. She'll take on a lot of the things that I've been doing. She's one of our facility specialists at the Toyota plant. So her, along with two other people, they pretty much make it happen. I get to talk about it, but they are the ones they're doing all the work. You can see all of our investments and stuff, so I won't go through that. So what I want to talk to you about is Toyota's 2050 vision. So a lot of it, as Ruchi mentioned, and the panelists, is resilience, being energy smart, being energy secure. So Toyota kind of coined it as 2050. So by the year 2050, there are these challenges that they want us to meet globally, not just in North America, but Toyota globally. And if you look at it, there's basically 6 challenges. The first 3 all deal with being carbon neutral, be it our vehicles, our manufacturing facilities, and research. But then we don't want to leave out the other aspects of environmental performance: water minimization, recycle-based society, and living in harmony with nature. And also promoting our suppliers and others in our community, the other key stakeholders, to be part of this initiative, because your company can do it, but if our community and our team members and other people aren't doing it, then you're just kind of like out there by yourself. So we really want to promote the 2050 vision, and hopefully some others can see something of interest in our 2050 challenge and maybe adopt it. Oh. I think I'll get the hang of this. Clark, can you just, thank you. Thank you, Clark. So today I'm just going to talk to you about the challenge number 3, which is reducing our carbon footprint in our manufacturing facilities. So, of course, we don't make energy, we just use it, but we have to be smart and we have to be responsible in our manufacturing facilities on how we utilize energy. We're trying to eliminate all the CO2 emissions. And when I say that, we can't just turn the lights off. We have to think of ways to reduce energy, think of ways to partner with companies to get renewables on site, look at power purchase agreement, different things like that. So first we want to minimize as much as possible and then invest in what we need to do to offset energy that we consume to manufacture. And of course we know that primarily, most of the energy used in a facility is natural gas or electricity. So if you just look really quickly, looking at some numbers from 2017, 3.85 million megawatt hours was used in our North American operations, and that's our manufacturing operations. And Toyota, of course, like most companies, we try to start with low-hanging fruit. So one of the things that is still most companies are doing is LED retrofits, correct? So one of the things that they did as a North American entity is said, hey, all of our plants will take out either metal halide or fluorescent bulbs, and we're gonna retrofit our plant to LEDs. So I think by the end of this year, pretty much all of our plants will be 100% LED, both inside and outside, meaning in our parking lots, on our marshaling yards, things like that. So that was one thing that every plant could join and say, we're doing this together. So that was a great win, something that we can announce to the public is, Toyota is doing this as a company. I'll talk to you a little bit more about what Alabama did. Of course, I like to be number one, so we put a little twist on how we installed our LED lights. Couple of other things that will save roughly 29 million kilowatt hours and roughly 17,000 metric tons of CO2. So that's something that we can highlight. So that's just an example because I didn't want to bore you about what Toyota North America was doing. So looking at Alabama specifically, we started off our facility at zero landfill 16 years ago, and we haven't sent any waste from our manufacturing facility to a landfill since we've started. We started biodiversity with tree plantings and different activities around our plant to bring in our native species about 10 years ago. We did some maybe pilot activities, but it didn't really pan out so well for our plant, but it was able to do provide learning for our other facilities with rainwater harvesting and battery storage. So in the next few years, we're gonna have a lot of hybrid batteries that's coming back to dealerships, or we don't want them to go in the landfill. So what we did is we were piloting how much useful life is left on those batteries that will be coming back to our dealerships. And can we do something other than just reclaim part of the lead or the metal out of them and try to recycle it? So we were able to charge these batteries and run our security building. Maybe in Huntsville, this wasn't the best project for us, but areas like our plant in Long Beach, our 2 plants in Mexico, I think they're really going to take this activity that we did and maybe implement it on a larger scale at their facilities. I know we partnered with Yellowstone National Park, and one of the facilities, one of the campgrounds out there, they're 100% off the grid due to our Camry batteries. So the hybrid Camry batteries actually provide, harvest the electricity and provides utilities to that campground. And then the last thing is all of our 2050 activities that we're doing. And I'm gonna speed up a little bit. But VFDs, please look into variable frequency drives at your plant. We were able to reduce our fan speed on our HVACs by 20%, but we saved roughly 50% of the amount it costs to run those HVACs. And of course, in the middle of summer, you have to have HVACs. Your team members won't work if they're not comfortable. So you got to be comfortable. So this was a really smart idea that, as long as they felt some air, they were comfortable, but then we were able to save a lot of money by just reducing that fan speed. Next one, remember I told you about the lighting project. So what we did is we put smart controls on our lights. So most of our other facilities just installed the LED lights. We went in and we partnered with a company here in Huntsville. Clark, tell me the name of the company. No, that did the data system. The guy, he's a technician here in Huntsville. I'll think of the name of it. But anyway, Orion actually worked with us on the fixtures, and they actually got us in contact with this company that has a branch here in Huntsville. And we were able to program each one of our fixtures in our plant. So if Mr. Cedric doesn't need his light at 100%, I could turn it down to 50%. Where if the A&M students need 100%, I can keep theirs up at 100%. So it's very tailored, independent of each production area. And we were able to see an additional 50% of savings on top of what our other plants were, just from installing these smart controls. So that's something that I would encourage you guys to look at. That motion sensors are good, but this was a lot better. We can go in and look at what the health of each one of our fixtures in the plant. And then finally, compressed air, that's a big cost. Probably it's the lifeline of most manufacturing facilities. And it's also probably the largest cost, maybe with the exception of the summertime, because we do have to cool the plant. But we were able to go in and install these, some controls on our compressors and put in this high pressure accumulator tank. And by doing that, we were able to reduce the pressure in our plant from 91 to 85. And as you can see, we saved over 1 million kilowatt hours just from this project. And we're trying to actually go in and lower it even more. It also was part of the resilience. So this tank also has helped us when a compressor didn't start. So we had enough capacity in this tank to keep the lines running until another or the next compressor in sequence was able to start up. So when you're thinking about projects too, think about how you can persuade your management to do something for that resiliency. So that was a win-win on both fronts for us at Alabama. And that's it, and that's just a snapshot. I know you guys will probably have some questions, but those are just some of the things that we're doing within Toyota and Toyota Alabama. Thank you.
We can ask questions all together at the end if you want, unless there's a burning question now. Okay.
Oh, I figured that's what we were doing.
Okay. All right. Well, next we have Duane Howell. He is that still the right title? Plant Services Manager? That's fine. Okay. He's the Plant Services Manager at Polaris. And I recommend if anybody, I don't know, maybe I shouldn't say this, but if you can get a tour, tours are free. Okay. They are amazing. I just recently went on a tour about a month ago, and Duane took me around, and it's fantastic to watch how much assembly and manufacturing is going on, the welding. It's quite spectacular. I get excited seeing all that. Duane joined Polaris in February of 2016 as the Plant Services Manager to help complete the construction of the Huntsville facility and start up the operation. He joined the first TVA Strategic Energy Cooperative in September of 2017, working with local businesses to establish an energy management program at Polaris, which will be completed this summer. Mr. Howell holds a bachelor's and master's degree in chemical engineering. Way to go, just like me. But not from, yours is from the University of New Hampshire. So, Duane?
So if you haven't been out to the facility, that is the front of the building. We make Rangers and Slingshot. If you haven't seen a Slingshot, it's one that kind of looks like the Batmobile. Kind of 2 front wheels, 1 run rear wheel. So we make about 300 Rangers a day and another 30 to 35 Slingshots a day. So we do about 335 vehicles a day. Just kind of walk you through a bit of the timeline. We're sitting on 505 acres, right? And we did groundbreaking June of 2015. First unit rolled out the door May of 16. So groundbreaking to production in 11 months. So to say it was a bit of a sprint is a bit of an exaggeration, is definitely underselling it. We have about 750,000 square feet of production space and then another 180,000 square feet of warehouse space. That was finished a little bit later. We had that first Ranger unit roll out in May, and then we brought the Slingshot product line in from Iowa. First units rolled out in August of 16. And to put it in a little bit of perspective, when we opened in May, we had about 400 employees, and we ended this year over 1,300. All right, so it's been, it has been a sprint for sure. Now, I would be lying to you if I told you in all of that, energy efficiency was a top priority. All right? Surviving day to day was a top priority in the first year.
Yeah, it's true.
There we go. So what we did do is, we really took our first year to catch our breath. I'm not gonna lie, and we really started focusing on it kind of in that summer of 17, started looking at what we needed to do. So in September 17, we had been approached by TVA, along with about 10 other local companies, large energy users here in North Alabama. And we joined the first TVA energy cohort. So I had moved down here from Vermont, and coincidentally, I had actually been part of this same program in Vermont about 4 years ago. So it was kind of neat to see 2 launches in 2 different areas and just kind of see what was the same and what was different. I was joking that apparently all the consultants in this area all come from Oregon, because I think I've dealt with 3 or 4 different ones now between the 2 programs, and they all come from Oregon. So one of the first things we did is we put together a cross-functional energy management team, and honestly, in the beginning, we kept it pretty small, right? It was my facilities management group, the environmental health and safety group, and 1 representative from finance to kind of help us with validating projects and doing some of our baseline financial work. So we didn't go huge. We didn't have this big giant launch. We kind of had a group of about 6 or 7 of us that were working on it regularly. And one of the first things we did, in a lot of places you really get hung up when they start to do energy studies, that they don't have tons of sub-metering in place, and we didn't either. Basically, we have 6 electrical substations or subfeeds. Each of those are metered, but below that, we really don't have any visibility. But what we did, and it worked really well, we basically just did a motor inventory, right? So we sit there and said, okay, let's just document by area every single motor horsepower, and then give an estimate of how often it ran, whether it was 100%, an 80%, a 60%. And that just gave us a rough direction of, hey, where are our opportunities, right? And then we did the same thing with lighting, right? So it was kind of our motor inventory and our lighting inventory, just to give us a direction. So that was important. We also then expanded that to compressed air. So we basically had an energy map and a compressed air map that we're looking at kind of both of those. We did already have an employee suggestion program if people had ideas on how to increase productivity or quality, or had a safety suggestion. So it was a pretty easy expansion to take that and just add energy efficiency as a category. So that was one of the ways we started getting in ideas from the team on what could be done. And then, and this is an interesting one. So I guess it was, let's just say April-ish of 2018, not only has Polaris grown here very quickly, Polaris has grown incredibly fast. So if you look at Polaris, I think in 2010 we were less than $1 billion company, or just about $1 billion, and last year we were over $6 billion, right? So when you grow that you grow that fast, and a lot of that was acquisition, right? Again, much like when we were starting up, what was important is just kind of keeping everything on the rails. So sustainability, while we had processes in place, we were really good about reporting it. In fact, I think 2016 or 17 might have been the first year we actually included in our annual report kind of a diversion metric and a CO2 metric, right? So it was very new to us. Well, we joined the Fortune 500 last spring. And some of the immediate feedback we got from the investment world was, hey, now that you're part of the Fortune 500, you get measured against all the other Fortune 500 groups and companies, right? And long term, not even long term, we need to see the sustainability scores start getting up into a certain range. So there was definitely a push to, we were fortunate that we were kind of ahead of the curve locally, some of the work we had done, and that started kind of getting spread to the other sites to kind of start forming that baseline. So we did have a kickoff of a corporate-wide sustainability project. And really what that looked at was both opportunities supply side, what should we be looking at for our energy portfolio? Should we be paying for wind credits and solar credits and everything else? What was reasonable to look at for on-site generation, depending on our site? So we're here, we have a big plant in Monterrey, Mexico. We have a big plant in northern Minnesota. So, and all of those have different utility rates. So what might work in Huntsville may be totally unfeasible in Minnesota, and may be perfect again for Monterey. So that you really had to look site by site based on how the utilities were set up and what the utility rates were to kind of see what was possible and made sense. And then we also looked at the the demand side? Were there projects that we were doing at one site that were easy to drop and put into another site? Through that, the energy management team that we started here kind of did a slight evolution to kind of be a broader sustainability team, kind of a green team, looking at all energy and all waste. And then the other thing that we did that was kind of neat through the TVA project, DOE actually has a program called DOE 50001. Now, ISO 50001 is your energy efficiency standard, and DOE 50001 is kind of the self-audited pre-assessment to going for ISO 50001, right? So part of what we did through that TVA program was we all did an initial baseline assessment. Where are we on that scale? When you kind of get to 100%, that's saying, hey, if you're interested in going for 50001, you should be ready because you've got all the pieces in place. So one of the things that we found that was pretty important was make sure that we had some quick, impactful wins. And there was definitely headwind, right? So I won't even begin to lie. It was really hard to explain to upper management that there were all these really cool opportunities at a brand new plant, right? Because the assumption is, well, of course we did. We made every great decision during the startup of the plant. There shouldn't be anything that you can go find to go and do. And of course that wasn't the case. And we did big ones and small ones, right? So talking about fans on the far left there, one of the things we did initially, and again, if you don't have air conditioning in Alabama, you're going to have a pretty unhappy workforce. Well, the first year we were open, we didn't have any ceiling fans. We were trying to control the temperature 100% through our HVAC system. And to keep the employees comfortable, if it got much over 73 degrees on the production floor, it was starting to become a problem. So that winter we put in, there's a brand name for them, but basically they're high volume, low speed fans, right? That's the generic name. And we put them on VFDs based on temperature, right? So, because what was inevitably happening was turn them up, turn them down, turn them up, turn them down. We said, no, we got a little temperature controller. It's going to adjust the fan speed up and down based on the temperature in the area. And what we found is with those fans, all of a sudden we could go from keeping the building at about 73 degrees to keep everybody happy to about 75 with the air movement, right? So it was a pretty substantial change. So the savings there, that is strictly the savings we had with the fans running. That doesn't really account for what we save for the HVAC units being able to run at a higher rate. Similar to what happened at Toyota, when the plant was set up, we were just running the air compressors at too high a rate, right? We kind of did what was safe. And through a series of turn it down 5 PSI, turn it down 3 PSI, turn it down 2 PSI, when did we start having equipment that had problems? We took almost 20 PSI out of our system, right? So that was a huge, and that cost zero. That was simply just playing with the system and figuring out which piece of equipment was going to go into alarm first. And then just some of the stuff is just simple things like timers, right? So we've got 100 robotic weld arms in that plant making frames. And there's big dust collectors to get all the weld dust. Well, people were supposed to turn them off at the end of shift. And I would tell you 98.9% of the time, they never got turned off at the end of shift, right? So we simply put in timers that said, okay, program the production schedule. At this time, shut them off. 10 minutes before shift starts, turn them on. And that saved almost 800,000 kilowatt hours a year, right? And with about $400 worth of timers on each one of them, right? So sometimes it doesn't have to be the big $1 million LED project or the big giant controls project. None of these were capital projects. These were all simply just reevaluating how we did what we did every day. So what's going on in this coming year? Again, trying to push process now at this point. There really weren't any energy standards for new capital acquisitions, right? Nothing was really written into our terms and conditions. All right, so we're working with the purchasing team in order to kind of get that pushed out. The other thing we're doing is we actually are improving our submetering. It's about a $400 adder to put a little wireless submeter in that we can pull in do a quick and easy utility. You know, when you're doing a $500,000 capital project, the project team doesn't even see it, right? So we've just worked with our local maintenance team and said, look, every time we quote an electrical installation for a new piece of our capital equipment, add the meter, right? We've done quite a bit this just so far, the end of last year into this year, with kind of regular little informational blitzes. We have a daily newsletter that goes out to the team. So every couple of days, we'll just kind of do a did you know fact and just put in different information about either home energy use or something that's going on at the plant, just to kind of keep it front of mind. And we put together an energy dashboard. One of the big things that came out of the TVA project was trying to put together essentially a predictive model that we could sit there and say, okay, hey, based on the average temperature outside and the number of units you're planning to run, here's how much energy you should consume. And then what we can track over time with all these little projects, how far do we vary from that? And that gap is your savings, right? So trying to put together that energy dashboard has been a pretty substantial project. We do have a couple of larger capital projects that we're kind of greasing the skids to do for next year. As crazy as it sounds, we built a brand new facility that's almost 1 million square feet with not a single LED light in it. Not sure how that happens, but anyways. So that's one of the big projects for us, is we do actually have to come right back in and do an LED lighting retrofit for all of our high bay. And then really just that final, the TVA project will wrap up in September. So then we'll go from kind of that hosted project team to kind of just something that's more self-driven. So that's really kind of what's on the docket for this year. I think that's it. That's it.
Duane, you had mentioned, I think, some oversizing of HVAC too at some of the, yeah. So that's another common problem. I'm sure it's on your list of things to look at. Okay, so our next guest is Rudy Hornsby. He's the Senior VP for Operations at Huntsville Hospital. We talked a lot today about resiliency, and I think as commercial sites go, a hospital has so many resiliency requirements because they have to be operational 24/7. And so just talking efficiency is really not enough when we talk about, our military bases and especially our hospitals. So I'm excited to hear from Rudy. He grew up in Arab, Alabama, and then attended Auburn. He received a and he received a BS in building science in 1977. After college, Mr. Hornsby worked for Hereford Construction Company, managing the light commercial division of the company. In 1980, he began his career at Huntsville Hospital in the facilities department. Currently, Mr. Hornsby is a senior vice president of the support services. This includes responsibility for architectural design and construction, plant operations, real estate, parking and security, food services, biomedical, material management, logistics, environmental services, and a lot. So he's got a lot on his plate, and I can vouch for that. When I visited him, he always had a line out his door of people probably asking for his time to think about a project. And if you don't know much about Huntsville Hospital, it's growing. It's not just in Huntsville, even though that's what the name is. In Athens and Hampton Cove and all these and remote, smaller areas are being helped by Huntsville Hospital, which really brings about better medical facilities for areas that wouldn't normally have it. So we're really proud of what Huntsville Hospital has been able to do. Please welcome Mr. Hornsby.
Thank you. It's the first time I have done this in this setting, so I just took a little guess at what maybe we should talk about, get grounded a little bit. I'll try this thing, see if point that direction. Thought we might talk with what's the utility bill, or what's the utility budget. The only point of this is just to make the point that we do worry over what we're doing with utilities because it's a substantial expense to the hospital. This has been higher. A couple of years ago, it was about 11.8, so we have dented it a little bit, which has been hard to do while we're growing. I mean, it's just difficult to feel like you're gaining any ground. You feel like you're just treading water all the time. If you want to visualize that for the system, meaning the other outlying facilities, probably be a little bit more than double. We're a little bit less than half of the whole.
Okay.
So, you know, it's a big number to talk about. And to try to give a little insight, well, I went too far here, a little insight about how we establish what we want to work on. One of the first things we did with looking at LEDs, and this is 2012, I thought it was, I see that. So it's been a while, but, you know, I have everybody knocking on the door every day. I mean, people coming in, and everybody's come to save me, and they're going to save my kids, and they're the answer to all my dreams and everything in the world, and they can fix everything, you know. And somehow you've got to establish what do you want to put your energy into or what you want to spend your time on, and it's a big organization, so even when you decide what you want to do, you've got to convince the board and the management and everybody else to allow you to spend some money toward the endeavor. So we do that by isolating a project somewhere that we can absolutely ascertain the facts about the project. So we had a parking deck, 420 Lowell parking deck, and the parking deck has no heating, cooling load. It's just lights. It does have one elevator in it that never runs. But we knew that if we could just do a project on the parking deck and relamp it, we would get a really true read on what LEDs did switching to LED. And so you can see we had a monthly bill that was just consistent. I mean, it was within $20 or $30 a month because there was not much variability of $1,700 a month, and after we finished the project, it was $796. So we took that and went to our board and got support to say we need to be doing LEDs everywhere we can do them as fast as we can. So we've been doing that ever since, but you know, with 4 million square feet here in town, it takes a while to get lights changed, but we change lights every day. And change is frustrating because, or it is to me, in the sense that I'm trying to get everybody to go the direction I want to go, get them lined up, rowing the boat in the same direction. And, you know, you turn around and your maintenance guy's out changing ballast and tubes, you know, even after you've adopted this. And so finally you have to go do things like just take it out of the purchase vendor list where they don't have a way to order ballast or a way to order tubes, or they'll keep changing ballast and tubes, you know. So we've taken that out. They don't have any way to do that. Now we're trying to push this to the other hospitals in North Alabama, where I think there's 14 of us now, if I remember right. And we're in all different states of repair and condition. You know, some of the hospitals were about to go under before we ended up stepping in, so they've let everything go, and some of it's pretty rough. We have come back and done a number of projects since then. One of them, I didn't bring the numbers, but one we just completed this last summer was a little heat recovery unit we put in at Madison. It's a little chill master unit that takes heat from the return chill water and preheats the hot water with it, and we managed to run 2 months in the winter with our centrifugals off. And so we were trying to get $9,000 a month savings out of it, and it's producing about $15,000 a month. So we've bought another one that we just are installing in Maine right now, and Marshall North, Marshall South look like two good candidates to put the same thing in. We had some tornadoes a few years back that you may remember, and we spent about a week of craziness trying to run a hospital, and went through $300,000 of diesel fuel in about the first, I don't know, 3 days, a little less than 3 days. We were running 24 generators, and had generators from all over the southeast in here, and you know, we use about 1 million gallons a day of water, and water was about to go down, so we sent 2 generators, loaned 2 generators to the utility to keep the water up, because we had to have it, and kept it up for the community. Loaned a generator to the Arab water, and I was just loaning generators all over the place.
We probably should have borrowed.
But we went through that, and you know, it's tough going through that time, but you learn a lot from having to survive that. And we had been where we would upsize our generators, try to put mechanical load on or other things on the generators. We would have to have generators anyway. But between EPA, you know, who don't want your generator run, and carbon stuff, we've reversed our philosophy, and we're going back to where we're trying to shrink the size of our generators, and we're looking at combined heat and power to do mechanical loads and some different strategies to do that. We've put a 50 kW solar array on the Med Mall just to get a little feel for solar. So, you know, we have all these opportunities where we've got some little something going all the time, and if it works, then we put that in the mix and we try to do it everywhere. Y'all probably know we have a tram, and the tram is electric, of course, and it's on an emergency generator. So we have 2,500 people a day ride the tram. We move patients, we move materials and goods and food and all sorts of things. So when you have something happen with the grid, it's a great thing to have, that you've got a way to connect the facilities. And then we couldn't get gas out of the ground, so we had to take generators and hook to a pump at the neighboring station and to get gas to put in our vehicles so we could run our trucks and do the things we need to do. We have a fleet of about 150 vehicles. And so that caused chaos because it was the only place in town you could get gas, so people lined up around the block for, you know, 3 or 4 blocks, and the police had to come referee fights in line for the gas and all this kind of stuff. And so, you know, we now have electric vehicles, we have natural gas vehicles, we have a natural gas filling station behind Women's and Children's on our, off of our gas meters so that we can fill our trucks, still have diesel, still have gas. We have now just hired 6 months ago a dedicated energy person to do nothing but the energy and monitor the energy every day. We just got utility tracks established, and he's trying to get his stuff set up so that he can monitor what's changed on a daily or hourly basis so we can keep up with what we're doing. You know, we can't turn everything off. We turn a lot of things off. We used to think we couldn't turn anything off, but now medical office buildings at night, we turn them off. I mean, just turn them off. Nothing beats off. So we just turn them flat off. Even in the wintertime, doesn't matter. I mean, it holds the heat to get through the night. But I can't throttle ORs, you know, so I've got places that are hands off and other places we can be aggressive with. That just may be my last slide, I believe it is. Yeah. So I'll be here for questions if you've got any, and look forward to talking to you. Thank you.
Yeah, and I'm glad Rudy mentioned the idea of hiring an energy manager, which was a new, you know, it's a cost, but it has some worth for sure because then he's dedicated to that. So that's one of those challenges that, you know, they're addressing. Next, I'd like to introduce Keith Woodbury. Keith is a professor of mechanical engineering at the University of Alabama and the director of the Alabama Industrial Assessment Center. Is anybody familiar with IAC? Okay, so we've got the next 2 speakers are both involved with their respective IACs, and I find it very exciting because this is kind of the future for how energy work is going to get done. It's going to come out of these centers. The Alabama Industrial Assessment Center is one of 28 centers funded by the US DOE EERE to educate engineering students, employees in energy efficiency through on-site assessments of industrial manufacturing facilities. Dr. Woodbury has led student teams over 200 energy assessments, identifying efficiency opportunities throughout the manufacturing facility. At this Alabama IAC was named the 2011 Center of Excellence by the Department of Energy. So, Keith, or Dr. Woodbury, sorry.
Thank you. I'm glad to be here. I appreciate Energy Huntsville inviting me to participate in this summit, so I'm hoping that I can contribute to your conversation here. As Runchy was saying, we're one of 28 centers located across the U.S. This graphic from the U.S. Department of Energy shows the university logos primarily for those centers. The one there at Alabama has a little red circle on it. There you go, to try to highlight that's where we fit in. but the centers are concentrated primarily in the eastern part of the state, of course, eastern part of the United States. That's where most of the industrial facilities are, more sparse in the west and then along the west coast, of course.